Let's take a look at some operations on strings. First one we'll look at is the operator called in. And that just checks to see if some character or string is in a substring. So for example, let's take a look at is A in A, E, I, O, U, the vowels. Of course it is, so that has a true value. Is X in the vowels? And of course the answer is no. So in it checks for membership in a string. We can also use for to walk through a string. So for example, we can say for CH there's characters in a string. Let's use the A, E, I, O, U again. Print the character and we'll put a comma after it so it doesn't do a return. So for now will walk through the string A, E, I, O, U, printing each character. If I pick my river, the Merrimack River, I can say for characters in river, print the characters. And we see it walks through the variable river, which is the string Merrimack, prints the characters one at a time. Now, sometimes we also want to get both the character and the index. And for that, there's this operator called enumerate. And we will enumerate the river. But that doesn't just give us the characters, that will also give us the indices. So we have to have two values that are coming out of this enumeration, and now I can print the character and the index. And we see characters, each index followed by the character. So there's just sometimes that you'll want that, and that's kind of a handy thing to have. Now for mathematics, we had functions, and as we learn Python, we will learn a number of functions. One common one is the length function, which is shortened to len. So what is the length of river? That's how many characters are in there. There's 9. Remember, the indices went from 0 to 8. There were 9 characters, so the length of river is 9. How many vowels did we have? E, I, O, U. And we see that there are 5 vowels there. Functions, as you remember from mathematics, return a value. So when we ask what is the length of river, it comes back and tells us that it is 5. And in computer, actually, and in mathematics, we would say that the function length returned a 9 or returned a 5. Now there's a special kind of functions that are called methods, and they use a different notation. They operate on the string itself. River dot lower, for example. Now, first of all, notice that as soon as I did the dot, I got all the possible methods that I could use. So, for example, let's count. Let's count the R's in river, and there were 2 of them. Let's see, what else might we do in there? We could scroll down the list, and let's do river dot lower, and that makes everything lowercase. The only one that wasn't was the first character, so let's go upper. River dot upper makes them all uppercase, and in fact now we can say is it upper? Is everything uppercase? Wait, let me back up a little bit. Notice river itself didn't change. So and that's partly because say river is immutable. So I said river.upper. That function returned a new string, and that new string was uppercase, but river itself did not change. Much as when we looked at length of river, that didn't change river itself. These functions don't. If I want to capture that, say our river in caps, just making up a name here, river.upper. Now we see that river caps. We hung on to that, but river itself is still unchanged. I can look at, is river, is that all uppercase? No. But how about river caps, the one that we changed into uppercase? Is that all uppercase? And the answer is yes, it is. So that would be a true Boolean expression. Another one that we might do that is pretty handy to have is, suppose I have a string which contains digits, number 42, special number there. Num dot is digit. So the Boolean ones, the methods that return Booleans start with is. So is num, does that only contain digits? The answer is true. Let's pick something else, like we'll call 42x. And now, does num2 have only digits in it? And the answer, of course, is no. So that's one way that we can check to see whether something is made up all of digits or not. That kind of comes in handy. Finally, let's take a look at string format. This helps us out in printing things out. Let's take, for example, a floating point number, x, and now I want to make a string to print that out. So if I just want print x, we of course get the whole number there. But suppose I did print percent 0.3f is a number. And we can, so the 0.3f is saying 3 digits of precision for a floating point number. Which floating point number? That's specified at the end. So this will print the floating point number. So the x, the value of x, will be used where f is specified, and the point, so the percent says we're specifying some formatting here. The 0.3 says, well, we're only going to show 3 digits to the right of the decimal point, the precision, and also notice that it did round up. So we often use formatting when I want to print out floating point values in a nice way. Another common thing to do is to print things out in a table. So if we go back to our enumerate, let's enumerate the whole Merrimack River. And if I simply say prints the character and the index, actually I got that backwards, didn't I? It's the but Python doesn't care about that. So the first one, what comes out of enumerate is first the index and then the character. I call them by the names in reversed order. Let's fix that. But while we're doing that, notice that the letters and numbers didn't print very nicely in columns. So let's see if we can fix that up. First of all, I'll go through and print the index before the characters, just because that doesn't look very nice. Now let's print them a little, let's actually print them in columns. So we use D for digits. Actually, we use it for ints is really what we're doing because index is coming out as an int. And let's put that in the numbers in a field of width 4, and we'll do the strings in a field width of 5. And now now I've specified that I'm looking for a number, which is D. Why that's there, it's historical, and then a string. So now I need to specify a number, which was my index, and actually that's an int, and my character, which I called CH. Now we'll see that they come out nicely in columns. Compare that, let me scroll up a little bit to where you could see, particularly once you got down to two-digit numbers, they didn't line up very nicely. Here they did. The default for the numbers was right justified. If I wanted to left justify those numbers, I can put a negative in front of the indicator. And now we see that we have justified numbers to the left. And notice how they shifted over, so that's because they're in a field width of 4. They're now at the left side of that as opposed to the right side of that. So we use formatting like that often for lining things up in columns, and then also a common place to use them is when we use them with floating point values. So we took a look at some operations such as in, which is really a membership, for, which let us walk through a string. We saw a function such as len, which gives us the length, and some methods, and there's lots of string methods. There's a table in the book which doesn't even list them all. And finally we finished off with formatting. Hello, thanks.